Let us look at proposition number 25 of book 10 of Euclid's Elements. The proposition says the rectangle contained by medial lines commensurable in square only is either rational or medial. We are given a rectangle contained by a medial straight lines AB and BC. Now what we have to prove is that this rectangle is either a rational rectangle or a medial. Let's see how we can prove this. AB and BC are commensurable in square only. That is the other condition for AB and BC. So the first thing we do is describe the square AD on AB, and let's call this point as D. So this is the square AD on AB. Next, we describe the square BE on BC. Let's draw the square on BC and let's call this as O and let's call this as E. So this is our square BE on BC. AD and BE are medial squares because they are on medial lines, AB and BC. Set out a rational straight line FG. Let's draw a line FG. Apply the rectangular area GH on FG equal to AD. Equal to the square, we have to draw a rectangle. So this is a rectangle GH on FG equal to AD. Apply the rectangular area MK on HM equal to AC. So here again we have to draw a rectangle equal to AC. Apply the rectangular area NL on KN equal to BE. Let's mark these points. So here FG is some straight line that we have taken, rational straight line. On that we have drawn a rectangle equal to the square AD. Then on HM we have drawn a rectangle equal to the given rectangle, and then on that we have drawn a rectangle equal to this square. FH, HK, KL are in a straight line. FH, HK and KL are in a straight line. Now GH and NL, GH, rectangle GH and NL are medial. Why? Because square AD and BE are medial. Since they are medial, these will also be medial because they are equal to each other. Now FG, HM and KN, they are all equal to each other. GH and NL, GH and NL are applied to rational straight line FG. See, they might be applied to different lines, but they are all equal to each other. So we can say GH and NL are applied to rational straight line FG. FH and KL are rational and incommensurable in length with FG, because remember AB and BC are commensurable in square only, and these are equal to these squares. So in length they are incommensurable. AD is commensurable to BE. Why are they commensurable? Because they are drawn on two lines which are medial, and AB and BC are commensurable in square only. So AD is commensurable with BE. So which means GH is commensurable with NL. GH is commensurable with NL. Why? Because they are equal to AD and BE. So now we can write this as a proportion. GH is to NL as FH is to KL. Parallelograms between the same parallel lines are proportional to their sides. FH is commensurable in length with KL. Why? Because GH is commensurable with NL. FH and KL are rational straight lines commensurable in length. FH and KL are rational straight lines commensurable in length. Therefore, the rectangle FH by KL is rational. DB is to BC, DB is to BC as AB is to BO, because AD is commensurable with BE. AB and BD are equal. BO and BC are equal. So they are in proportion. But AD is equal to GH. AC is equal to MK. And CO, or we can say BE, is equal to NL. So we can say GH is to MK, GH is to MK as MK is to NL. And we can also say FH is to KH or HK is equal to HK is to KL, which means product of the extremes and product of the means. So FH by KL is equal to HK square. Since FH by KL is rational, FH by KL is rational, we have seen that. HK square is also rational. And if HK square is rational, that means HK is also rational. Now, if HK is commensurable in length with FG, HK is commensurable in length with FG, then HN is rational. This rectangle is rational. We can say HN or we can say MK to refer to this rectangle. Now, if HK is not commensurable in length with FG, remember FG is equal to HM. So that means HK is not commensurable with HM. So if they are not commensurable, then KH and HM are rational straight lines commensurable in square only, which means what? It means HN is medial. That is the definition of a medial. Finally, since HN is equal to AC, AC is either rational or medial. So that is proposition number 25 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.